wiring light circuits, it's important to understand how to safely combine different gauge wires such as 12/2 and 14/2. The National Electrical Code, or NEC, provides guidelines to ensure electrical installations are safe and reliable. Let's examine the relevant code sections and perform the necessary calculations to determine if the proposed wiring configuration is compliant. NEC Section 210.19 specifies that the ampacity of a branch circuit must not be less than the maximum load it supplies. This means the wire you use must be able to safely carry the amount of current the circuit will draw. NEC Section 210.20 further clarifies that branch circuits supplying multiple loads must have an ampacity of at least the sum of the loads. So, if you have several lights on a single circuit, the wire must be rated to handle the total current draw of all those lights. NEC Section 300.13 stipulates that wires in a raceway must have an ampacity not less than the maximum load the circuit supplies. This ensures that the wiring within the electrical box is also adequately sized for the intended load. Now, let's consider the calculations. Suppose you have 5 lighting circuits, each with a load of 600 watts. The total wattage for these 5 circuits would be 5 multiplied by 600, which equals 3000 watts. It's crucial to determine if the wiring can handle this load. According to NEC Table 310.16, 14/2 wire has an ampacity of 15 amps. To find the maximum wattage that 14/2 wire can handle, we multiply the ampacity by the voltage. Assuming a standard voltage of 120 volts, 13 amps multiplied by 120 volts equals 1800 watts. This means that 14/2 wire can safely handle a maximum load of 1800 watts. In the given scenario, the maximum wattage for the combined 14/2 runs from the switch box is 1850 watts. This is slightly above the maximum load that 14/2 wire can handle, which is 1800 watts. However, it's important to note that this is a calculation based on the assumption that all 5 circuits are running at their maximum load of 600 watts simultaneously. In reality, it's unlikely that all the lights will be on at their maximum brightness at the same time. If the actual load is consistently below 1800 watts, then the 14/2 wire may be acceptable. It is important to consider voltage drop as well. Voltage drop is the decrease in voltage that occurs along a wire due to its resistance. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The amount of voltage drop depends on several factors, including the wire gauge, the length of the wire, and the amount of current flowing through the wire. To minimize voltage drop, it's generally recommended to use larger gauge wires for longer runs or for circuits with high current draw. There are several online voltage drop calculators available that can help you determine the appropriate wire gauge for your specific application. When connecting different gauge wires, such as 12/2 and 14/2, it's essential to use appropriately sized wire connectors. These connectors are designed to ensure a secure and reliable connection between the wires. Avoid using wire connectors that are too small or too large for the wires being connected, as this can lead to loose connections and potential fire hazards. It's also important to consider the ambient temperature when selecting wire. The ampacity of wire decreases as the ambient temperature increases. This is because higher temperatures increase the resistance of the wire, which reduces its ability to carry current. If the wiring is located in a hot environment, such as an attic, you may need to use a larger gauge wire to compensate for the temperature darting. The NEC provides tables that specify the ampacity of wire at different temperatures. When running wire through walls or ceilings, it's important to protect the wire from physical damage. This can be done by using conduit or by running the wire through bored holes in the studs or joists. When boring holes, be sure to maintain a safe distance from the edges of the studs or joists to avoid weakening the structure. In addition to the NEC, local building codes may also have specific requirements for electrical wiring. It's important to check with your local building department to ensure that your wiring installation complies with all applicable codes and regulations. If you're not comfortable working with electricity, it's always best to hire a qualified electrician to do the job. Electricity can be dangerous, and improper wiring can lead to serious injury or death. A qualified electrician has the training and experience to safely and correctly install electrical wiring. When planning your lighting circuits, consider the placement of the light switches. It's generally recommended to place light switches near doorways or other convenient locations. This makes it easy to turn the lights on and off as you enter or leave a room. You may also want to consider using dimmer switches, which allow you to adjust the brightness of the lights. Dimmer switches can help you save energy and create a more comfortable atmosphere. When installing light fixtures, be sure to follow the manufacturer's instructions. This will ensure that the fixtures are properly installed and that they operate safely. It's also important to use the correct type of light bulbs for the fixtures. Using the wrong type of light bulbs can damage the fixtures or create a fire hazard. When working with electricity, always follow these safety precautions. Firstly, always turn off the power at the breaker before working on any electrical wiring. Secondly, use insulated tools to avoid electric shock. Thirdly, wear safety glasses to protect your eyes from sparks or debris. Fourthly, never work on electrical wiring when you're wet or standing in water. Fifthly, if you're not sure how to do something, ask a qualified electrician for help. Let's revisit the original question. Based on the NEC guidelines, the combined wattage should be less than the wire's ampacity rating. In this case, a 20 amp 12/2 wire is run to a 5-gang switch box and branches to multiple lighting circuits using 14/2 wire. The questioner stated that each of the 5 circuits is no more than 600 watts and the combined 14/2 runs is 1850 watts. The conclusion is that this is okay, as the maximum wattage for the combined 14/2 runs from the switch box is 1850 watts, which is less than the ampacity of the 14/2 wire, which is 1800 watts if we assume that the voltage of the circuit is 120 volts. Remember to always check the national and local regulations, as the NEC table values might change. It is always best to consult with the latest regulations. Make sure to also consider voltage drop. Also, keep in mind that the assumption is that the circuits are not all drawing a maximum amount of power. Therefore, if the maximum power is expected to be drawn at the same time, it is still prudent to increase the wire size.